Hi guys, how are you? क्या हाल चाल है भाई? गुड मॉर्निंग गुड मॉर्निंग गुड मॉर्निंग गुड मॉर्निंग एवरीबॉडी. क्या हाल चाल है? कैसे हो आप लोग? How are you doing? I hope you are doing good. You're keeping yourself healthy, keeping yourself fine, keeping yourself hydrated, and you're doing your studies as usual. Okay. These in these times, it is more important to keep yourself healthy. If you ever feel a hint of fever or sore throat or anything, always visit your family physician and talk to your parents. Do not ever think that falling ill is like sign of weakness. Sometimes the body gives up. Okay, we also fall sick. I fall sick more usual than not. I would not say. सर आप जमशेदपुर से हैं? Yes. Hello, hello. So you have a doubt? Yes, Akanksha, go ahead. Please ask your doubt. So, anyways, we until now have. So this is coordination chemistry, which is going on right now. I am fine. I am fine. NCRT table 9.1. Okay. Akanksha, I'll just mention something. So I live in Bangalore. Yes, I live in Bangalore. So you know each and every place in Rourkela? I guess yes. I passed out my college in the year 2008. So I hope I guess like think I know a lot of famous stuff, like whichsoever places we used to hang out. I still remember them. Anyways, Akanksha, if you have a doubt in NCRT table 9. I do not have NCRT at hand right now. However, what you can do is you can drop me an email at saurav.goswami at vedantu.com. Okay? Hello, Aman Chaudhary. Okay, chalo. Let's start today's session. Anyways, if you have any doubts, I'll just write something. So if you have any doubts, so our topic for discussion today is nomenclature. So yes, I have seen that Hanuman statue. I guess it is a little ahead of the railway station towards, I don't remember the name of the place. Anyways, in case you have any doubts, you can just drop a mail to saurav.goswami@vedantu.com. Okay? Hello, party. Okay, chalo. So let's start today's session, nomenclature part 2. In yesterday's session, we started learning some basic terminologies. We have completed Werner's theory and we have started learning some basic terminologies. I'll do a quick revision of what basic terminologies that we have read, and I would request each and every one of you guys to sit with a pen and a paper so that you can make a note of some important things. Because doing that will always enhance your ability to grasp things and learn stuff. Okay, so you are studying live with me for the reason that you want to study with a guided. It should be a guided learning. I am teaching and you are learning simultaneously, and it would not give a lot of good results unless you write things down. Okay. Okay. Hello, Nachiket. Good to see you over here. So, So let's start with the first terminology that we had discussed yesterday, that is coordination sphere. I had told you that any complex can be represented. So if you take any complex can be represented as MLX, and you can put NY, or you can represent it as NYMLX. Both these representations, MLX, both these representations are slightly different from each other. And what do they represent? What do they represent is that something which is very well known to us. If you know about how to write the formula of salts, you must have read that NaCl is written like this, which means the entity which is written on the left hand side is the cationic part, and the entity which is written on the right hand side is the anionic part. So entity which is written on the left hand side is cationic, right hand side is anionic. Similarly, Na2SO4, this is cationic and this is anionic, isn't it? So if I'm writing it like this, I write something within the square bracket and write something on the right hand side as well. So this becomes a cationic part and this becomes the anionic part. Okay? Yes, exactly, Harleen. Nomenclature is very important for boards. But you're not focusing only for boards, na beta. If you are writing N on the left hand side and this on the right hand side, that means this is the cation and this is the anion. And nothing is being written on the left or right, it is just the square bracket. That means this is neither a cation nor an anion, it is a neutral compound. Okay, neutral compound. No, ionic bonds are non-directional in nature. Ionic bonds are like attraction towards chocolate, okay, or attraction towards a cake or a pastry, whatever you call it. The moment you pass in front, if you are in the vicinity, so let's say there is a cake present on the table, you might be present anywhere in the room, you would be attracted to it. Okay, that's like an ionic bond. A covalent bond is directional, which is like a handshake. If a person is shaking hand and is putting his hand in front of you, you have to put your hand exactly where he is putting it. Otherwise, that will not be called a handshake. Okay? Okay? Is that clear? So whenever you take a complex, whatever part is written within the square bracket is known as the coordination sphere. The part within a square bracket is the coordination sphere, and whatever is outside is the counter ion. Okay, part inside the square bracket is the coordination sphere, and part outside is the counter ion. Clear? Is that clear? Part outside is the counter ion, part inside the square bracket is the coordination sphere. Now inside the coordination sphere, what you have is a central metal atom or an ion. For example, in whatever this is the, if I take this this complex, and inside the square bracket the metal is nickel. Okay, is this clear? So inside the square bracket the metal is nickel, inside the square bracket the metal is cobalt, inside the square bracket the metal is iron, but they have their respective oxidation states as well. So metal with their respective oxidation states will be known as the central metal atom or the central metal ion. So that is the central species, and everything else surrounds it. Okay, That is the central species and everything else surrounds it. So this is the central metal atom or ion. This is the central metal. So since nickel carries a +2 charge, cobalt carries +3 charge, iron carries +3 charge, so they will be known as central metal ions. Okay. Yes, man, you can attend the session. Take as much benefit as possible. I'm sorry. In this case, nickel is bonded to CO. CO is carbon monoxide. Carbon monoxide is neutral. The oxidation state of this is 0. So nickel's oxidation state is also 0. And so this becomes a central metal atom. Central metal atom. But these have charges, so they will become central metal ion. Okay. Clear? I hope this is understood. Your whatever metal is present inside the square bracket could be classified as a metal atom or metal ion. Metal atom when it has 0 oxidation state, metal ion when it has a particular oxidation, a positive oxidation state. Okay, chalo. And whatever is present apart from the metal is known as the ligand. Okay, whatever is present apart from the metal is known as the ligand. Now let's understand this a bit. So let's say I take a complex which is K4FeCN6. Understood? K4FeCN6. No. The charge, there is no rule that the charge will be same. Okay, there is no rule that the charge will be same. You have to calculate charge. So, can you tell me what is the counter ion? What is the counter ion? What is the ligand? And what is the central metal atom or central metal ion? Can you tell me in the chat box that what is the counter ion? Can you please tell me? Yeah, you can understand. You can understand. The counter ion is K plus. Counter ion is K plus. Counter ion is K plus. This is just a revision. Okay. Ligand is Cn. Cn always carries a negative charge. So you have to always mention that it is Cn minus. Central metal atom or central metal ion is iron. But is iron in 0 oxidation state or is in positive oxidation state? Iron is in 0 oxidation state or in positive oxidation state. So if the oxidation state of iron is X, then I can say that potassium's oxidation state is +1. So that makes it +4. +1 times 4 potassium plus X. And Cn is -1. So -6, that should be equal to 0. So X should be equal to +2. So it is a central metal ion, which I should be writing it as +2. Okay. It is not 0. It is not, then oxidation state of iron is not 0. Oxidation state of iron is +2. So whenever you write counter ion, whenever you write ligand, whenever you write central metal atom, it is vital that you represent their respective oxidation states as well. You represent their respective oxidation states as well. Otherwise, what will happen is that will lose its, I would say, significance. That will lose its significance. Let's take another question. Let's take another question. Suppose I take a compound like this. PT Cl4 2 minus. In this case, what is the counter ion? What is the ligand? What is the central metal atom or ion? Please tell me. Please tell me, in PtCl4 2 minus, what is the counter ion? What is the counter ion? PtCl4 2 minus. Can you identify the counter ion? Is there? Very good, Shubhodaya. There is no counter. Very good, Tejashwini. There is no counter ion. We do not know what is the counter ion. Not applicable. I would say not applicable. We cannot identify what is the counter ion. Ligand is Cl. Cl comes with a negative charge. Very good. So ligand is Cl minus. And central atom or central metal ion will be central metal atom. Yes, Sabha, central common counter ion nahi hai. Ligand will be Cl minus. Ligand will be Cl minus. Very good. And central metal atom or ion will be, you always indicate the oxidation state as well. Sorry guys. Okay, Pt2 plus. Clear? Is that clear? Please tell me a yes if this part is clear, so that we can move on to the next part. Is this part clear? Yes. Very good, Bhavya. Very good, Akanksha. Yes, Prateek. We'll get to that a little later. Yes. Is this clear? Very nice. Will that dissociate in water? Anything which is present inside the square bracket does not dissociate. Let's go with that. Okay. Chalo. Basic terminologies. The last one is ligand. And what are ligands? Ligands are things which are present inside the square bracket which bind with the central metal atom or ion. They bind with the central metal atom or the ion. Now these ligands can be of various types. Ligands can be small molecules, they can be large molecules, they can be macromolecules, they could be anything. For example, in hemoglobin, the ligand is a huge porphyrin ring in which the central metal atom is iron. Iron. Okay. So you have to understand that ligand can come in various shapes and sizes. However, the basic feature of the ligand will be to bind with a metal. Okay. Is that understood? Is that understood? Small ions, large ions, it could be macromolecules, but it all depends on the fact that what is the complex that we are talking about. Okay, their property is to bind with a metal. Now let me give you a very simple idea. If you take a complex, in a complex, I am talking of the coordination sphere. Let's say you write it as MLX. Okay, if you write it as MLX, always remember that in coordination chemistry, M is treated as a Lewis acid. Lewis acid is electron acceptor. Metals, the central metal atoms or central metal ions are always treated as Lewis acid. Clear? Central metal atoms or central metal ions are always treated as Lewis acids, while ligands are treated as Lewis bases, which are electron donors. Okay, a easy way to remember a Lewis acid is that LAA, Lewis acid acceptor. and BED, base electron donor. This is an easy way to remember what is a Lewis acid and what is a Lewis base. So Lewis acid is an electron acceptor, Lewis base is an electron donor. Always remember that ligands, all of these ligands, they behave as electron donors. All of these ligands behave as electron donors. Clear? All of these ligands behave as electron donors. So if a entity does not have electrons to donate, it cannot behave as a ligand. It cannot behave as a ligand. Please do remember, any species which does not have electrons to donate cannot behave as ligands. Cannot behave as ligands. So here comes my question to you guys. Okay, please tell me a yes in the chat box if you have understood this, that ligands are electron donors. They are Lewis bases, they are electron donors. Any species which does not have electrons to donate cannot behave as a ligand. Okay, cannot behave as a ligand. Please tell me in the chat box that if you have understood this. Yes? Very good. Very, very good. Chalo. So, give me an answer to this question. Can H plus behave as a ligand? If I take H plus, can it behave as a ligand? If I take H plus, can it behave as a ligand? Please tell me yes or no. Yes, Pratik, you should always start from NCERT. There are a lot of, we'll discuss, ligand classification we'll just discuss next. Can H plus behave as a ligand? Very good. Very, very good. H plus cannot behave as a ligand. It does not have electrons. It does not have electrons. Understood? Does not have electrons. Similarly, NH4 plus, can it behave as a ligand? NH4 plus, can it behave as a ligand? H plus does not have electrons. NH4 plus, can it behave as ligands? Can it behave as a ligand? Very good, Ajita. Very good, Ajita. Can NH4 plus behave as a ligand? Answer is no. Answer is no. Because you can see that in NH4 plus, all the electrons are bound in the bonds. All the electrons that are present are in the bonds. There are no electrons that can be shared. There are no free electrons. There are no lone pair of electrons. So an important characteristic of ligand is the presence of unshared pair of electrons which you can donate it to something. You want to donate something, so you should be having unshared pair of electron. Suppose you want to donate money to some organization, you want to do some charity, so that money cannot be the one which you have put in your bank, or that money cannot be the one which you have invested somewhere or you have given to your parents. That money should be the surplus money. It could be the surplus money. Okay, chalo, very good. Let's move on to the next thing. Counter ion we have already studied. So let's start with these questions. Let's discuss these questions. Designate the coordination entities and the counter ions in each of these compounds. Designate the coordination entities and the counter ions in these compounds. Okay, so let's start with K2NiCN4. K2NiCN4. The coordination entity What is the coordination entity? Coordination entity is nothing but the coordination sphere. So coordination sphere will be NiCN4. NiCN4. And what is the charge on the coordination sphere? It is minus. And what is the counter ion? Counter ion, that is K plus. Okay, counter ion is K plus. Coordination sphere, sorry, NiCN4 2 minus. I'm sorry, NiCN4 2 minus. There is 2 unit of positive charge, so NiCN4 will have 2 unit of negative charge. Cr. Just a moment. Cr En whole thrice Cl3. In this case, counter ion is Cl minus, so coordination sphere will be Cr En3 3 plus. Cr En3 3 plus. Next, Fe4 FeCN6 whole thrice. Okay, Fe4 FeCN6 whole thrice. The name of this compound is Prussian blue. The name of this compound is Prussian blue. Okay, it's called Prussian blue बोलते हैं. Prussian, it appears as intense blue pigment. Fe4 FeCN6. Okay, Fe4 FeCN6 3. Now, what is the counter ion? The counter ion is Fe3 plus. Counter ion, we'll discuss what is En. We'll discuss what is En. En is known as ethylene dye amine. It is an abbreviation of a ligand which is ethylene dye amine. And the coordination sphere is FeCN6 4 minus. Okay, FeCN6 4 minus. Understood? FeCN6 4 minus. I hope you have understood this completely. In the last one, PtCl4 En 2 NO3 2. It looks as if there is no counter ion and the whole thing is coordination sphere. You do not have. Okay, I will get to that later. We'll discuss the nature of ligands in just a moment. Okay, we'll discuss the nature of ligand in just a moment. I hope this is understood to you guys. Okay, I hope this is understood to you guys. Okay, chalo. How could the central metal atom and the counter ion be same? Could be same. You do not have a control on what exists. You can only observe it and give some inferences. Okay, central metal ion is Fe2 plus. Counter ion is Fe3 plus. Check kar lo. What is the oxidation state? Fe2 plus. This is Fe2 plus. This is Fe3 plus. Both of them are different. Okay. Next terminology is coordination number. Now the coordination number is a specific number which is assigned to the central metal atom or central metal ion. Okay, central metal atom or central metal ion. Balaji, I will discuss ligand charges a little later. Let's focus on something which is it is not going on. It will come a little later. So just wait. So if I take any complex, for example, I take a complex like this. How many ligands can you see over here? How many ligands can you see over here? In the first one, you can see 6 ligands. How many ligands can you see over here? Good morning, good morning. Ibis, no central metal atom never carries negative charge. Okay, what is the number of ligands over here? 6. What is the number of ligands over here? 4. What is the number of ligands over here? 4. So that represents the coordination number. That represents the number of ligands inside the coordination sphere represents the coordination number. We will discuss more about coordination number a little later, but for now this is the simplest way of looking at it. Okay, this is the simplest way of looking at it. Clear? I hope this is understood. Okay, chalo. Can you tell me what is the oxidation state of the metal in this complex ion? What is the oxidation state of the metal in this complex ion? So the metal is Pt. What is its oxidation state? What is its oxidation state? What is its oxidation state? What is the oxidation state of metal in the +4? Very good. The answer is +4. The answer is +4. It is not +2. Okay? +4. So do not have a control on what will be the oxidation state, what will be the number of ligands, what will be the nature of counter ion. Whenever a question is presented in front of you, you can just predict on the basis of the information which is given to you. Do not form any preconceived notions. Okay? Okay. Pahul sir has already taken sessions on chemical bonding. You can watch them. Okay. Now, there are new 2 words, homoleptic and heteroleptic. Homoleptic means all ligands are alike. So if I say that this is a homoleptic complex, it means all ligands are alike. And if I say something as heteroleptic, that means all ligands aren't alike. If I have to identify okay, let's start with the first one. Is the first complex K4FeCN6 homoleptic or heteroleptic? First one is homoleptic or heteroleptic? Please tell me. First one is homoleptic or heteroleptic? First one is homoleptic. Second one, homoleptic or heteroleptic? Always remember to identify whether all ligands are alike or not. You should always consider only the coordination sphere. You should not take into consideration the counter ion. Okay, don't make a mistake over there. A is homoleptic. Second one is heteroleptic. Very good. Heteroleptic. Third one is again homoleptic. Fourth is heteroleptic. Okay. Clear? Man, I am here to teach. Okay. If you should understand that science is at times challenging, at times easy, at times interesting. You should always welcome science in whichever form it comes if you want to become good at that subject. Okay, so chalo. So A, B, C, D, homoleptic, heteroleptic, homoleptic, heteroleptic. Clear? Chaliye. I hope this is clear to everybody. I hope this is clear to everybody. Chalo. Let's move on to the next thing. What is the coordination number of copper in this complex? CuNH34SO4. Please tell me what is the coordination number of copper in this complex? What is the coordination number of copper in this complex? Answer is 4. Yep. Answer is 4. Coordination number can never be negative. Don't ever say D. Coordination number is a positive whole number. It can never be negative. No. Coordination number is not +2. You are talking about charge. Coordination number is the number of ligands present inside the coordination sphere. Okay, it will be 4. It will be 4. Okay, it is 4. Clear? Chalo. Next, identify the Lewis acid and Lewis base components in each of the following complexes. So I'm just gonna write Lewis acid over here, Lewis base over here, and we start with the first one. Let's start with the first one. That is HgBr4 2 minus. Please tell me HgBr4 2 minus. First one, Lewis acid is Hg2 plus. Very good. Very good. Always write the Lewis acid with its respective charge. The Lewis base is Br minus. Second one, NiH2O 6 2 plus. NiH2O6 2 plus. Now H2O is neutral. H2O does not carry any charge. So nickel's oxidation state will become 2 plus and this will become H2O. Third one, PdCl2 NH3 whole twice. So palladium's charge will be, please tell me what will be the charge on palladium. What will be the charge on palladium? Pd. What will be the charge on palladium? Pd2 plus. Very nice. Very nice. Ajita, very nice. And Lewis base will be Cl minus and NH3. Very good, guys. Very good. Next is AlOH4 minus. AlOH4 minus. So Lewis acid is Al3 plus and Lewis base is OH minus. Fifth one is AgCN2 minus. So Lewis acid is Ag. Lewis acid is Ag. Yes, exactly. Lewis acid is Ag with a positive charge, and Lewis base is Cn minus. The next one, the last one is CrCO6. CO is carbon monoxide. It is also known as carbonyl. We will learn the names of ligands a little later, but carbon monoxide has zero charge. So if carbon monoxide has zero charge, in that case, the ligand will have zero charge. So metal will have zero charge. I hope this is clear. Okay. Everybody, please tell me if you have understood this. Everybody, please tell me if you have understood this. Everybody, please tell me if you have understood this. Yes? Clear? Clear? Okay. Are you finding this difficult, easy, interesting, challenging? Where would you place it? Are you finding coordination compounds easy, difficult, interesting, challenging? Where would you place it? Where would you place it? It's easy and interesting. Chalo. Very good. Thank you. Thanks a lot, guys. Okay. Lovely. Lovely. Chalo. It's moderate. Always good to say if anything is challenging, please say openly that it's challenging. If you qualify something as challenging, that does not mean that you are a bad student or a good student. No. Finding something challenging is like knowing the limitation. It requires. Okay. It's not a boring chapter. Okay. It's not a boring chapter. It's actually a very interesting chapter. But the problem is that you have to understand things develop slowly from easy to difficult or interesting. Okay. Chalo. Let's start with the classification of ligands. So ligands, whichsoever we have studied until now, can be classified in a number of different ways. Okay. Ligands can be classified in a number of different ways. The first method of classification of ligands is by identifying their charge. So if ligands are ligands can be neutral, positively charged or negatively charged. Let's identify some neutral ligands. Neutral ligands can be CO. Neutral ligands can be H2O. Neutral ligands can be NH3. Neutral ligands can be CH3NH2. Neutral ligand can be PPH3. PPH3 is known as triphenylphosphine. Please make a note of this. Triphenylphosphine. Hey bhai Vigneshwar Mishra, you are too late to the class. We have already discussed double salts and all in the very first session. We have already discussed double salts. We आज की क्लास में आप आके पूछ रहे हो. We have already discussed this. Okay? Qualitative analysis will start later. Right now we are discussing coordination compounds. Qualitative analysis will start later. So CO, H2O, NH3, etc. I will put etc. There are so many different types of ligands which are neutral in nature. These are some common ones. Positively charged ligands are a little rare. Okay, positively charged ligands are a little rare. Most common examples are NO with a positive charge, NO plus nitrosyl unit or nitrosonium ion, or NH2 NH3 plus. This is known as a hydrazinium ion. Okay, hydrazinium ion. hydrazinium ion. Negative ligands are very, very profound. For example, OH minus, for example, all halide ions. You can take NH2 minus, you can take NO3 minus, you can take CO3 2 minus, you can take SO4 2 minus, you can take oxalate, so many things. Positive ligands can be written as Lewis bases because the positive charge is not present on both atoms. Okay, positive charge is not present on both atoms. Positive charge is present on one of the atoms, the other atom donates electrons. So like this NH2 donates electron but not this nitrogen. Okay, this NH2 donates electron but not this nitrogen. In NO plus, so N double bond O, OH, this is HNO2. From HNO2 we obtain NO plus. If you treat it with H plus, you will obtain H2O plus N double bond O with a positive charge. Now nitrogen still has lone pair of electrons. Oxygen still has lone pair of electrons. Okay, so this lone pair of electron on oxygen can be donated. This lone pair electron on nitrogen can be donated. Okay, is that clear? I hope this is understood. I hope this is understood that we have ligands which can be classified on the basis of charge. So there may be a number of different ways of classifying them. One of the basic ways of classifying them is on the basis of charge. Okay? On the basis of charge. Any doubts? Any doubts? Clear? Chalo, very good. Please hit the like button, share and subscribe so that your friends know that the class is going on. The next mode of classification, एक बार और यार एक बार फिर से देख लो यार, रिवाइंड करके देख लो, ठीक है? बस और 10 मिनट ही बाकी हैं क्लास के, ठीक है? चलो. The next way of classification of ligand is on the basis of denticity. Denticity मतलब क्या होता है? What is the meaning of denticity? What is the meaning of denticity? Denticity. No problem, man. You can dislike. If you come late, then you can't expect na ki everything goes according to you. Okay. So denticity. Denticity is dent represents teeth. Dent represents teeth. Dent represents teeth. Okay. So dent means teeth. Denticity means, so ligands are like ligands are holding the metal atom with their teeth. Okay. Denticity loosely translates to the fact that ligands are holding the metal atom with their teeth. Okay, ligands hold metal atoms with their teeth. Okay, so ligands hold the metal atom with their teeth. So if I hold something with my teeth, how many teeth I'm using to hold that is known as denticity. So how would I know? How would I know that what is my denticity? So I have classified my ligands on the basis of the number of, so if I go to a doctor, if I go to a dentist and he looks at my teeth and he identifies how many teeth do I have, then that will become my denticity. Okay, because I can utilize all of these teeth while eating. While my son, who is like about 2.5 years old, will have less teeth than me, so his denticity will come less. Okay, his denticity will be less. If I take a really old guy whose teeth all, or a really young baby, okay, a really teeny baby who does not have his milk teeth, the denticity will come 0. They cannot hold anything with their teeth. They do not have teeth. Okay? Okay. Now, try and understand that when it comes to ligands, what is their teeth? For a ligand, the teeth is, the donor site. The donor site. That means number of donor atoms. Number of donor atoms. Okay? Number of donor atoms will become the teeth for ligand. This is हमारे लिए teeth. What is our teeth? Similarly, ligand's teeth is the donor site. So I have divided ligands on the basis of denticity. If there is one donor site, if there is only one atom which can donate, then I will say that it is monodentate. If there are two atoms which donate, then I will say that it is bidentate. If there are three atoms which donate, it will be known as tridentate. 4 atoms which donate, tetradentate. 5 atoms which donate, pentadentate. 6 atoms which donate, hexadentate. Is that clear? Please tell me if you have understood this. Hello Rohit, stop spamming, man. Why are you spamming? Hello Rohit, please stop. Ronit, please stop, man. Stop spamming, man. Okay. So in a monodentate, they have only one donor atom. Okay. In a monodentate, we have only one donor atom. Clear? We have only one donor atom. For example, fluoride, chloride, bromide, H2O, NH3, Cn-, NO2-, OH-, CO, H-, even P. So Py is the abbreviation of pyridine. Pyridine looks like this. This is pyridine. Pyridine has only one donor site. Okay, this is the donor site for pyridine. Clear? No, denticity and coordination number is not the same. Denticity and coordination number is not. Denticity is the number of donor sites. Coordination number is defined for the central metal atom. Denticity is defined for ligands. Okay, clear? Chalo. Now, bidentate. When I come to bidentate, my things start becoming interesting. The first and the most common bidentate ligand is ethylene dye amine. If I elaborate this, ethylene dye amine is written like this. This is ethylene dye amine. This is ethylene dye amine. You can see that there are 2 donor atoms. Book to follow for inorganic, you can follow NCERT, you can follow J.D. Lee. These 2 books are very good. So these 2 are donor atoms. Okay, so how many donor sites can you see over here? You can see 1 donor site, 2 donors. So there are 2 donor sites. 2 degree number, secondary valency and coordination number are Li. Oxalate. Yes, clear? Oxalate, 2 donor sites. Ethylene diamine is abbreviated as EN. Please do remember, ethylene diamine is ethylene diamine is abbreviated as EN. No, Sri Balaji does not always represent the number of lone pairs, because the number of lone pairs in oxalate, if I just to refute your claim, if I look at the number of donor atoms in oxalate, then number of donor atoms is 2, but the number of lone pairs is a lot. So in oxalate, the number of lone pairs will be, if I calculate, the number of lone pairs will be 1, 2, 3, 4, 5. This has a negative charge. This has a negative charge. 1, 2, 3, 4. 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 plus 4, 10. Okay, 10 donor atoms. 10 lone pairs are present. It does not always tell us the number of lone pairs. No, it tells us the number of donor atoms, number of donor sites. Okay, it tells us the number of donor sites. So please do not mistake it as number of lone pairs. Clear? Is that clear? Please tell me if you have understood this. Bidentate, 2 donor sites. Tridentate will be 3 donor sites. Tridentate will be 3 donor sites. So tridentate, the most common example of tridentate is DIEN, diethylene triamine. So diethylene will be written like this: CH2, CH2. This is diethylene. I will write this as diethylene. And I will use NH over here, NH2 over here, NH2 over here. Now it will become 3 donor sites. There are 3 donor sites. Why don't the other 2 atoms act as? So if I try and understand, I'll give you a simple example. I want to hold this cup. Okay, I want to hold this cup. I can hold this cup with my 2 hands. I can hold it with my 1 hand, but let's say I want to have a better control. I will hold it with 2 hands. I have 2 legs as well. Can I hold the cup with 2 hands as well as 2 legs? Can I do that? Can I do that? Can I hold my cup with 2 hands and my 2 legs? I do hold few things with my legs. I can hold a piece of cloth which is present on the ground with my leg. I can hold football with my leg. But can I hold this cup with my 2 hands as well as 2 legs? Can I do that? Please tell me in the chat box. Can I do that? So that is the case with oxalate as well. Oxalate is using 2 to donate. Okay, it cannot utilize. The other 2 oxygen atoms are present in the opposite direction. Okay, it is present in a different direction. So they cannot donate. They cannot donate. They cannot donate. Clear? So this is diethylene triamine. Diethylene triamine. Sorry. Diethylene triamine. So this is what happened. Array. Yeah, just a moment. So there's NH2 and this will become the donor site. This will be the donor site. This will be the donor site. This will be the donor site. Okay. So I hope you have understood. So please tell me what is oxalate. C2O4 2- is oxalate. C2O4 2- is oxalate. We are left with tridentate, pentadentate and hexadentate. So in tomorrow's class we will discuss, thank you. Okay. Okay. In tomorrow's class we'll discuss tridentate, pentadentate, hexadentate, and we will start learning nomenclature, how to name coordination compounds. Like organic nomenclature, coordination compounds also have a systematic nomenclature. It is much easier and it's much more fun to do. Okay. So no, I'm not better than him. Okay. Sumati, please watch the lecture once again, beta. You were not present from the beginning, so it could be possible that you have not understood things. But if you are present from the beginning, if you're present from 9:30, there is no possibility that you will not be able to understand things. Okay. So I'll take leave right now, guys, and my another class is gonna start in just about a minute's time. So bye bye. Have a lovely time. Please do like, share, and subscribe. And please do come back tomorrow at 9:30. We'll be discussing nomenclature. Okay. Thank you. Thank you. Sure. Bye bye.